3.2 Maximum minimum on an interval and its graph. Determine the absolute extrema of the function. Illustrate your answer by sketching its graph. So here's question number 1. Y equals to x cubed minus 3x squared, where x is between minus 2 and 1, both included. And part B is y equals to 1 plus x to the power of 2 over 3, where x is restricted within the domain of minus 8 and 1, both included. Now I'd like you to solve these questions and then look into my solution. Now here is how I'm going to do it. So whenever we have a function which is bound from both sides, that means it has a lower boundary and an upper boundary, then it will surely have maximum or minimum value, provided it is a continuous function within the given domain. Now both these functions we know are continuous functions, so they fulfill our restrictions. Now, to find the critical number, so what we need to find is the value of the function at lower boundary, which is minus 2, value of the function at the upper value, which is 1, and also the value of the function at critical point. So first thing we should find what the critical point is. So that we can find by the derivative. So y dash is equals to 3x squared minus 6x. So we have taken a very simple example so that we can illustrate a point, right? And not get lost into calculations. Now if I want to equate this y dash x to 0, then what should be the value of x? So let's factor this. It will be easy for us to calculate the value. So we can factor out 3x and we get x minus 2 as factored form of y dash x. Now if I equate this to 0, I know my critical points will be at x equals to 0 and at x equals to 2, right? So let me say critical number now here. So critical number are my c values. So critical number is at x equals to 0. If I put x equals to 0, I get a 0 there for the derivative. And if I put x equals to 2, then the other factor is 0. So these are the two critical numbers for us. Now we need to test the value of the function at these critical numbers and on the boundary condition. So what we need to check is value of the function at minus 2, value of function at 1, value of function at 0, and value of function at 2, correct? At 2. So these are the values which we should check for. Now, as you can see here, x equals to 2 is not within our boundary, right? So since this is not in our boundary, we can just forget about it, right? So we will not check the value for the function at 2 since it is not within the given boundary, right? So to find the value of the function at minus 2, you just need to plug in minus 2 in the main function, which is y equals to x cubed minus 3x squared, correct? If you put minus 2 here, you get minus 2 cubed. So I'll recommend you to use calculator. You should use calculator. Find this answer, write it down. Now 3 times minus 2 squared, and that gives me minus 8, and minus 2 squared is 4. 4 times 3 is 12, minus 12, and that gives us a value of minus 20. Right, I hope the calculations are right. Now let's calculate at 1. If I plug in 1 here, I get 1 cube, which is 1, minus 3. And that gives me a value of minus 2. At 0, if I put 0 here, I get 0. So these are my 3 values. And from these values, we can always say what is maximum and what is minimum. So we get maximum value of 0. So that becomes maximum for us, right? And the minimum here is minus 20. So that is our minimum. So that is how we get maximum and minimum values for our function. Now the second part of the function is to sketch and show this on a graph. So we'll just make a rough sketch of the whole function. Now to make a sketch, it is better to write it in the factored form. So we can write this function as y equals 2. So let me rewrite this function, okay? So I have y equals 2. I can take x squared common. So I can take x squared common, and so I get x minus 3, right? So that means the zeros are at 0 and at 3, and we know our boundary is between minus 2 and 1, and at minus 2 I have a value which is minus 20. So let's say this is 3, this is 2, approximately, I'm just plotting some points, and this is 2. So at this value of 2, let me say that this value here is minus 20. So let me say this value is minus 20 for us, okay? So that is minus 20 for us. Now it has a 0, which is kind of a turning 0. It's a degree 2 0 here. So if you draw this function here, let me draw it in a different ink, right? So what you notice here is that this function will go like this, and then it has to turn from here, right? And then somewhere there it will turn and kind of go, right? So that is the function, and the solid line shows is the boundary for our function, right? Now what is the value at 1? 1 is minus 2. So 1 is here. So the boundary is, let me draw now boundaries. So this is, actually speaking, that is what the boundary is, right? So we have a boundary here at minus 2. So this is minus 2 for us, and that is 1. If you see, these are the values to be compared, correct? As far as the values are concerned, you know, at 0 we have the maximum, right? So this is the maximum value for us at 0, right? And the minimum is right there. So that is minimum. So minimum value is minus 20, which we have here, right? So therefore, we can write down our answer. So that is the graph which we're talking about. That is a dashed line, okay? So this solid part is a portion which is between minus 2 and 1. And as you can see, we have a graph here, correct? And the solution is that absolute maximum value is 0 and minimum is equal to minus 20, which is this value, minus 20. So that is the solution for this. Let me push this a bit on the top. Let's do the next one here. I've taken this with a purpose, and I'll show you what it really means for us. Now let's follow the same process as we did earlier. So what we will do here is find the derivative of the function. So derivative is, this is 0, and here we get plus 2 over 3 x to the power of 2 over 3 minus 1. So let me write 2 over 3 minus 1. Then we can write this as 2 over 3 x to the power of minus 1 over 3, right? So you multiply, it becomes 3 over 3. 2 minus 3 is minus 1, correct? And I can write this as 2 over 3, that is cube root of x, correct? I mean, this is 3, right? This is 3. So 2 over 3 and cube root of this. So from here, what is my critical number? So the critical number for us is a number for which y dash is either equal to 0 or it is undefined, right? So that is what we understand by critical number. So as you can see, the critical number is at x equals to 0, right? If I put 0 here, then y dash becomes undefined, something divided by 0. Now since we know our critical number, we need to now test the values at boundary conditions, which is minus 8, and then at 1, and also at the critical number, which is 0 for us, correct? Now if you substitute the values, minus 8 in this, what do you get? You get 1 plus minus 8 to the power of 2 over 3. You can use calculator, find the answer. We know one thing, the cube root of 8, or rather minus 8, will be minus 2. And when you square it, it becomes 4. So we get 1 plus 4, which is 5. If I write 1 here in the expression, I get 1 plus 1, which is 2. And for 0, I get 1 plus 0, which is 1. And clearly from here, we do have absolute maximum value of 5 and minimum value of 1, correct? So that is how you can find maximum and minimum value for this particular function. And now let me make a sketch of this function. So I'll make the sketch right here on the top. So let us say, let me sketch it here. So this is a transformed, I should say, this is the transformed x2 over 3. x2 over 3 function is like this, and if I transform it by 1 unit up, it will be kind of like this, right? So that is my function. You can clearly see that here we have a cusp. Since we have a cusp here, the derivative is undefined at x equals to 0, and that is also the minimum value. So that is the minimum value for our function. Now our boundary was between minus 8 and 1. That means the boundary was kind of something like this, right? Minus 8 and 1. So let me write down the boundary here, which is minus 8 and 1. So you can see at minus 8 it has a maximum value, right? So that value at minus 8 came out 5 for us, right? I know it is not to the scale, but gives you a fairly good idea of how things look like, correct? So that is how our function is, and we should draw this bound. Let means we have to draw this part of the function which represents a function bound within the limits of minus 8 and 1. Now here what is important to say or state is that we do have undefined derivative within the interval, but still we have an absolute minimum value, correct? Important thing is function should be continuous within the domain, right? So let's move on and do some more questions to get really conversant with this idea of absolute, maximum and minimum. Thank you and all the best.